Hello and welcome. This is going to be the first video on solving quadratic equations. Now, just like regular old equations, there's a lot of different ways that you can solve them, and it's going to depend on exactly the structure that you're seeing in front of you. So it's important that when you start solving a problem, you start to make predictions about what would be a good thing to do first and what might follow in the future, because that way when you're comparing and contrasting, you're going to be able to start figuring out some of these larger patterns and how we're always able to make the right move the first time. But let's first understand what a quadratic equation is. Now the word quadratic, even though it has the word quad inside of it, is actually referring to the number 2 and not the number 4. Now what it's implying in algebra is that the highest power in our equation is a 2. So a quadratic equation, there should be no power greater than the power of 2. And these are solved a little bit differently than our questions that we had at the beginning of the year where the power was only the first power, the invisible first power. So let's take a look at some old friends that have helped us out in the past when solving equations. You're certainly going to need to know order of operations, and that's going to tell you what takes priority first. Now, when you evaluate the order of operations, it's in a different order than solving using the order of operations. And it has to do with different layers of the equation. When you're solving, it's the process of undoing. So essentially, you're undoing PEMDAS. So you typically don't start with parentheses. You'll typically start with addition, subtraction. But again, it depends on every unique problem. There is a multitude of problems where you would actually start with parentheses first. But these are just some general terms to talk in. If there are like terms, you're best off to combine them. That reduces the number of terms in the equation and then has fewer distractions to deal with. And particularly we'll be working the most with inverse operations. So that's what I was talking about before when we mentioned undoing. So that's the process of stripping away numbers away from the x so that we can figure out the mystery number it is underneath its mask. So in general, the process is to undo all operations around x until the x is all alone by itself. So let's take a look at some examples right here. Our first example just starts off with a plain x squared. Just like plus undoes minus, and times and divide undo each other, a squared can be undone with a square root. So we apply this inverse operation to both sides of the equation. Now when this happens, we actually don't get one answer. You might say to yourself, oh, but I already know the square root of 9 is 3. But in this particular situation, it's actually positive and negative 3. And there's a very good explanation for that. When you think about the original problem, x squared, there's actually two instances that can yield a 9. If you squared regular 3, of course you get 9. But even if it were a negative 3, a negative times negative creates, again, a positive 9. So you got to be really careful when you're solving quadratics because there is often more than one solution. Sometimes there is exactly one, and sometimes there are no solutions, but often there are actually two solutions. So let's take a look at this one right here, b. You'll notice the x squared isn't by itself yet. We have this minus 16 here to undo. Well, I'll move it to the other side with our addition operation. And now we notice it has transformed into the problem A, where all we need to do is take the square root of both sides and realize that positive and negative 4 would both be appropriate solutions to the problem. Because again, if you square a positive, you'll still get a positive, and if you square a negative, it again returns a positive. In problem C, again, we're going to link it back to our first problem by trying to undo the operations around the x squared that we see. I see that there's a times 5 in front, so by dividing both sides of the equation by 5, I have transformed the equation again to be a single x squared. And as we've done twice already, I will take the square root of both sides to undo the square root, the inverse operation, letting me know that x is both positive and negative 2. D looks strikingly similar to the question right above it. However, there is one small twist there. you would say to yourself, alright, well, let's take away 36 so we can get our number on the other side of the equation. If x squared, however, equals negative 36, we've run into an issue. Over on the right, I've told you that when we square a positive 3, we get a positive 9, and when we square a negative 3, we also get a positive 9. And that's kind of giving us a hint right here that how could we ever square a number and get a negative? It seems as though if I choose a positive or a negative and I square it, I'm going to get a positive number regardless. So in this situation, we would say that there is no solution. If you wanted to be precise, you would say that there's no real solution because in the future you'll take Algebra 2 and learn about some numbers that aren't quite so real. You could call them your imaginary friends, and if you know what I mean, that's going to be a bad joke. So you'll learn about that in the future, but just think through the process and think about what we're trying to accomplish. We're trying to find a number squared, a number times itself that's going to give us the number on the opposite side of the equation. It turns out there's no way to multiply the same number twice and get a negative, so there would be no real solution. Watch out for those problems because from time to time they will pop up and they will cause you a headache if you don't know to end it too early. So what would be a great thing to do at this point in the video would be to pause, try and see if you can work through these on your own, and then I'm going to go through them in just a second. I've done most of the explaining up above, so I'm going to go through these a little quickly. If you feel like it was too quick, then just pause it, rewind. You guys have that freedom. You have the ability to do so. And try some more problems. So here we go. Maybe I'll spin around. Swivel chairs are nice. Okay, so let's solve these. Now I noticed I have a plus 8 next to my x squared, so let's undo it with a minus 8. That's telling me x squared is equal to 16. And I can undo the squared by square rooting, telling me that x is plus or minus 4. However, in this problem, f, I have times in front. So to undo the times 7, I must divide by 7. Now, what if you said to yourself, oh man, how did you do divide by 7 so fast? Well, there's a little bit of mental arithmetic going on. I know that 7 quarters would have given me 175, but even if you couldn't, you know you've got other options available to you. You have a calculator, or you can just straight up divide it like we learned in elementary school. And there's nothing wrong with that. When you're pressed for time, don't spend time trying to guess it. Just go ahead and say 7 goes into that 2 times, that's 14. Alright, subtract 35, it goes into it 5 times. So just go ahead and divide it. But we're still not done. Square root it, so x could be plus or minus 5. Over in this problem, we have double operations. So we've got to subtract the 2 first. 3x squared equals 108. We have that times relationship again. So dividing by 3 would tell me that x squared is 36. We need to undo the squared with a square root, so we get plus or minus 6 as our solution. Often, as I was saying, often you'll want to undo a addition or subtraction before you undo a multiplication or division. It's not that you can't, but we got to make sure that you stay consistent, that if you divided by 3 first, you would divide everything by 3, but since neither 2 or 110 are divisible by 3, it wouldn't be a good thing to do off the bat. But let's keep going. Subtract 10. So x squared equals 49, square root, telling me that x would be equal to plus or minus 7. Alright, some bigger numbers, nothing to be afraid of here. Plus 13 to both sides, 2x squared equals 162. Luckily, this is a nice number to divide by 2. 16 divided by 2 is 8, 2 divided by 2 is 1, so I broke that up. And the square root of 81 would be not 9, it would be positive or negative 9. Now the last problem you may remember from in class, I kind of threw this out there as a challenge just to see who was making some deep connections to what we did in first semester. And what we did in first semester was we learned how to deal with x's on multiple sides of the equation, and our goal was to move them all over to one side. So even though we have 1x squared and 4x squared on opposite sides, I could take away 1x squared from both sides, leaving me with 3x squareds. And now it's into the familiar zone. I see that I have a times 3 in front, so I can divide by 3. X squared is equal to 25. I could square root and square root again, but leaving me with the answer x would be equal to positive or negative 5. I'd like to point out that these were our basic solving problems where we were utilizing only the power of the square root to eliminate the squared and arrive at our possible answers for x. It is possible to get a double answer, so the same answer twice, and it is also possible to have no solution. So look out for those and the next few videos that I'm going to upload in just a minute. Go on to the next one.